Hi guys, and welcome to our second team teach, where we will be going over Module 2, Chapter 9, Geometric Figures. I'm Allison Harper.
I'm Elizabeth Phillips.
I'm Molly Davis.
All right, let's get started. Question 1 is for Molly. What is a corresponding angle?
Okay, so when you are looking at different angle types, a specific one that we know is corresponding, and that simply means that two angles are going to be exactly congruent, and the only difference is that they are separated by a line. So for example, over here on the left, you can see that this set of lines actually has two blue angles highlighted. That is actually representing corresponding angles. So when you look over here on the example, you can see, for example, angles 2 and 6 are corresponding. And so if you were to say that angle 2 was equal to 64 degrees, that means that angle 6 is also going to be 64 degrees as well. So that is corresponding angles.
You explained that very well, Molly.
Thank you. Okay. Oh. If that thing would go away. Is this Elizabeth?
This is Allison.
Oh, Allison, I'm sorry. The Zoom thing was in the way. Okay, Allison, can you tell me what is a vertical angle? Give an example of a vertical angle using the figure.
Okay, so a vertical angle are opposite angles that are made by two intersecting lines. And just as Molly said with corresponding angles, vertical angles have the same measurement as well. So if we look over here in our example, angles 2 and our given measurement of 63 degrees are vertical angles because they're opposite and they're made on intersecting lines. So angle 2 will also be 63 degrees. And another example of a vertical angle here is angle 9 and our given measurement of 61 degrees. So angle 9 will be 61 degrees as well.
Very good job.
Thank you. Okay, Elizabeth, what is a supplementary angle?
A supplementary angle is basically an angle or two angles whose sum is 180 degrees. So if you look at our box to the left, I have a little example. You have a straight line, and then you have a ray going right through. It's making two angles. The first one makes up 120 degrees. The second one makes up 60 degrees. And when you add those together, you get 180 altogether, which means that these are supplementary angles. So if you look at our box to the right, we have an angle right here with 100 degrees and 80 degrees. When you add those together, and they make up 180. So therefore, that would be a supplementary angle.
Great job explaining
Good
that.
job.
Thank you. Molly, identify the difference between supplementary and complementary angles.
Okay, so for number 2, I just wanted to kind of give an idea of how to tell the difference between a complementary versus a supplementary angle. So as you can see over here with this visual on the left, this is a complementary, and that just simply means that two angles are going to equal up to exactly 90 degrees. So you can see we've got 60 degrees and 30 degrees. And then over here on the right, we've got supplementary angles, which again, like just mentioned, is going to be two angles that equal up to 180 degrees. So we've got 180, and there you go, you've got 180. So that is kind of defining complementary and supplementary angles.
You did a good job.
Great job.
Thank you. Okay, Allison, how do you find the missing angle of a triangle?
Okay, so here is my triangle, and it's identified as angle ABC. And when you add A, B, and C together, you should get 180 degrees. But if you notice, we are missing the measurement of angle A. So we put angle A in our equation, We have angle B, which is 26, so we're going to plug 26 degrees in, as well as 74 degrees, and then we're going to set it equal to 180 so that we can solve for angle A. So we're going to add angles B and C together, which equal 100 degrees, and then we are going to subtract 100 degrees from our 180 to get angle A, which is 80 degrees.
Good job, Allison.
Good job.
Thank you. Okay, Elizabeth, how would you solve for A, B, and C in the following triangle, given the rules of supplementary and corresponding angles?
If you'll notice, our triangle that we're given is an isosceles triangle, which means it's going to have two of the same measurements. So we have 40, 70, and 70. We're wanting to find the measurements in our smaller triangle. And you can do this an easy way, or you can do it a little bit, not finding the right word. There's a little bit more difficult way to find it, which we're going to kind of walk through. It's really not that bad. It's actually pretty easy. In every triangle, we have 180 degrees, and we're going to start out with this bottom left triangle right here where we have 70 degrees. If you'll notice, with it being an isosceles and everything, the bottom two angles are going to be the same. So the bottom left corner of that triangle will be 70, the bottom right hand corner of that triangle will be 70, and then we just add those together and we get 140. So when we subtract 140 from 180, we get 40 for that top angle. And we can do the same thing with the top triangle, and we can subtract 40 from 180, and it's pretty much a repeat of our bottom triangle. Once you subtract 40 from that 180, you divide your sum, and you'll get 70 on both sides. And once you kind of figure that out, you start to notice a pattern in your triangle where every single one you have has 40 degrees, 70, and 70. Well, you can either go based off of this angle right here next to angle A, and you can add 40 and 70 and subtract that sum from 180, or you can simply just kind of follow the pattern. So the pattern that we notice here is that both of the bottom angles of each triangle have 70 degrees on them, and then the top angle of your triangle has 40 degrees, which means the angle C is going to be 40 degrees, angle B is going to be 70, and angle A will be 70.
Great job.
So Allison, how do you find the measurements of interior angles?
Okay, so there are 3 steps. Step 1, we are going to find the sum of all the angles in our figure. So our equation for that is n minus 2 times 180 degrees, and our n represents the number of sides on our shape. So there are 4 sides, so we're going to plug 4 in for n. So 4 minus 2 times 180 is going to be 360. And then we'll move on to step 2, which is solve for y. So we are going to take all of our angles and set them equal to 360. And we find that y equals 30. So step 3, our last step, we are just simply going to plug in 30 for y. And so 2y, which now equals 2 times 30, is 60 degrees. And then 4y, which equals 4 times 30 degrees, is 120 degrees. So our 2y angles are equal to 60 degrees, and our 4y angles are equal to 120 degrees.
Good job, Allison.
Great job.
Thank you. So Molly, can you explain the interior angle formula that correlates with this given polygon?
Yes, so just looking at a different polygon to give you another idea of how the interior angle formula works, we see again, we've got this formula up here, n minus 2 times 180. And so on this polygon, we actually have 8 sides. And so 8 minus 2 is going to be 6. And then you've got 180 times 6, which is 1,080. And then again, you're just using that same step, adding all of those interior angles together to get ultimately 54y. And then after simplifying, you get y equals 20. And then again, you're just doing that same rule, plugging in for y, and you get 7y is equal to 140 degrees, 3y is equal to 60 degrees, and 12y is equal to 240 degrees.
Great job.
Mm-hmm.
Thank you. Okay, Elizabeth, determine the measurements of each interior angle in the following concave polygon.
So we're going to follow the same steps that Molly and Allison went through. If you'll notice at the top under our question, we have our formula 180 times n minus 2, where n is equivalent to the number of sides. What we're going to do is we're going to count up our sides and we're going to plug it into our problem, which was our number of sides was 12. And then we just kind of solve for that. So 12 minus 2 is 10. 180 times 10 is 1800. And then we go and move on to the next step, where we add up all of our x's. So we have 8 1s, 8 x's, and then we have 4 3s, 4 of our 3 x's. So we just add all those together, we'll get 20, and we divide 1800 by 20, which will give us 90. So now we just plug in 90 for all of our x's, and we kind of figure out what the measurement for each angle is. So for every x that we have in our figure, it's 90 degrees. And for every 3x that we have in our figure, it's going to be 270 degrees. So Allison, what is the measurement of the interior angle in this figure?
Okay, so our equation for interior angles
It's pulling up sides.
Oh, yeah,
There we
sorry.
You're good. You're good to go ahead.
Okay, so we had to count our sides. We had to count our sides so that we knew what n was. We have 9 sides, so we are going to plug 9 in for n. And so that's 9 minus 2 times 180 over 9. 9 minus 2 is 7 times 180 over 9, and that gives us 140 degrees. So our interior angle is 140 degrees.
Good job, Allison.
Great job.
Thank you. Molly, what is the measurement of the central angle in the figure shown?
Yes, so when working with the central angle of a polygon or any shape, you are actually going to be using the formula 360 divided by n. And similar to the interior angle formula, n is just representing that number of sides. So for this specific polygon, we actually have 360 divided by 9 due to there being 9 sides. And that is going to equal 40 degrees. So that central angle is actually 40 degrees.
Good
Great
job.
Thank you. Okay, Elizabeth, what is the measurement of the exterior angle shown?
This one's going to be easy. If you'll notice, our exterior angle lines up with our shape. We can go based off of what Allison told us. And we can use that measurement that Allison gave us and substitute it for that side of the line to make 180 degrees or a supplementary angle. So what we're going to do, if we look back at what Allison did, she noticed that each interior angle of the shape is 140 degrees. Well, that angle right there plus whatever our exterior angle is going to make 180 degrees since it is supplementary. So we're going to go ahead and do 180 minus 140, and our exterior angle should be 40 degrees.
Great job.
You did a really good job explaining that.
Thank you. Allison, when talking about geometric shapes, what is a vertex and a face?
Okay, so I just wanted to kind of go over some vocabulary words before we get into our next question. So a vertex or vertices are the angular points of the shape. So with this cube here, every single point on the cube is a vertex or vertices. And as far as face, it is the 2D shape that makes up one surface of the 3D shape. So it is this flat surface right here, or it's also called the face of the shape.
Good job.
Great job.
Thank you. Molly, question 5 says, conduct a cube with vertices A through H.
Okay, so kind of using some of that information we just learned, you can see that we've got each of the vertices labeled with a different letter, A through H. And so that is kind of just giving you an idea of exactly where to find your vertices. And for example, if we want to look at a specific face, we've got face A, B, C, D right here. This is going to be a face. And then back here on the back of the cube, E, F, G, H is also another face. So that is just giving you an idea of where to find vertices and faces on a cube.
Good
Great
job.
job explaining that.
Thank you. Okay, Elizabeth, construct a tetrahedron in the figure below by connecting the following points.
So what we're going to do, when we look at our cube, you'll notice we see D, E, G, and H. We're just going to connect those points and kind of make a figure like this one. And that actually, if you'll kind of look at it, you'll notice that it actually forms a tetrahedron. And there's a picture to the right there. But all we did was connect our points, D, E, G, and H, and it gave us a couple of faces and vertices that actually lined up to make our tetrahedron in our figure.
Great job.
So I'm going to go ahead and ask my question. Can you construct an octahedron? So an octahedron is pretty much a polyhedron. It's got 8 sides, 6 vertices, and 12 edges. And whenever you go to actually draw it out and make an octahedron, it's going to kind of come up looking like this figure down below. So Allison, can you construct a tetrahedron?
Yes, ma'am. Okay, so a tetrahedron has 4 faces and 4 vertices. And you start off with a triangle. And a tetrahedron is also just considered like a pyramid, if you want to think of it that way.
Mm-hmm.
Oh, I was done.
Oh, you were good? I'm sorry. I hit buttons too fast.
No, you're fine. Okay, so Molly, can you construct, oh, this word kills me, y'all.
Icosahedron.
Icosahedron. I don't know why I want to say isosahedron. Okay, Molly, can you construct an icosahedron?
Yes. Okay, so the figure shown is an icosahedron, which is actually a polyhedron, which in simpler terms is just a 3-dimensional shape with all flat faces. And so for this specific polyhedron, we actually have 20 faces and 12 vertices. Each vertice is labeled with a red dot, and then all of the faces are just all of these little sections on the figure. So that is an icosahedron. And that is going to conclude our lesson for today. I hope you all found this really beneficial, and we will see you next time.